Today, we're going to start making this fantasy-style health meter. Let's go! Alright, so this health meter is a bit complex. And so we're not going to finish it in today's video, but we're going to make a good start. There are several different components that make up this effect, and we're going to make the first one today, and then complete the effect in the coming weeks. In this series of videos, we've been building a set of subgraphs that you can use to build user interface elements and other 2D effects. These are building blocks or shortcuts that make it faster to achieve the results you want. If you haven't been following along with the series so far, I've put a link in the description for each of these nodes so you can find the one that you need and then quickly jump to the video where I show you how to make it. So if I add one of these nodes to the graph in today's video, you'll know where to find it. So to start off today, we're going to build a new gradient node to add to the library. We'll build it in Unity first, and then I'll switch over to Unreal and build it there as well. So the core of the fantasy meter effect is the 3D sphere shape. So we're going to create a node that generates this effect. We'll start by selecting the gradients folder, and then I'll just right click and pick Create Shader Graph Subgraph. And we're going to call our new subgraph Sphere Gradient. And we'll open it up and get started. Alright, so the first thing that we need to do is to create some UV coordinates. So like I've done many times before, I'm going to create a new vector 2 called UV. And I'll select it and open up the inspector over here. And we'll pick Use Custom Binding and give it a label of UV0. Alright, now we're going to drag our UV coordinates in. And we'll add a branch on Input Connection node. Connect our UVs to the input and the connected. And then we'll create some default UV coordinates by creating the UV node and connecting that to the not connected port. And what that does is the input port of UVs, if it's empty, it's just going to default to the UVs that we already have. All right, so the next thing that we need to do to build our sphere is we want to give the user some control over the scale of the sphere. And so I'm going to add a scale node, and this is one that we created in that library of subgraphs that I just showed you. So here's our scale node, and if you don't know how to make this node, or you haven't been following along, you can find the scale node in the list of nodes in the description. Alright, so I'm going to connect up our scale node, and we're going to keep the pivot point at 0.5 here, but we do need to give the user control over scale. So I'm going to create a new float parameter, and notice that I'm not creating a vector 2, even though my scale input here is a vector 2. I want to create a float, and that is because spheres are symmetrical, or they're the same in x and y. So I can just create a float parameter called size, and we're going to default size to a value of 0.9. And we'll drag our size parameter in and connect it up to the scale port of our scale node. Alright, so that's going to give our users the control over the size of the sphere. Now we actually need to make the sphere. Right now we've got some nice looking UV coordinates, but they're centered kind of down here in the lower left. And we want to center them in the middle. And that's pretty easy to do. All we have to do is multiply, we need to multiply by 2. And then we need to subtract 1. This is an operation that we've done many times before. And what this is going to do is center our UV coordinates in the center instead of in the lower left. And now we're actually ready to make the sphere. The first part of the sphere that we're going to make is the depth. And to make depth, what I can do is do the dot product between my U and my V coordinates. So I'm going to add a dot product node. And basically dot product the U and the V with itself. And that gives me a nice gradient. It's basically measuring the distance from the center. So right at the center, I'm getting a value of 0. But then as we go further away, we're getting a higher and higher value until we get to about here, which is where our value reaches 1. Now, right now I have a linear gradient, and what I want to do next is make this into a curved gradient so that it will be the depth of my sphere. And I can do that by adding a saturate node to make sure that we clamp between 0 and 1. So when we get to 1 out here, it's just going to stay 1. Right here, when we get to 1, it's going higher and higher and higher, but I don't want that. I just want it to be 1 from this point on. So I add a saturate node. And now I'm going to 1 minus the value here so that I can invert these. And this way, my values are highest in the center, and then they fall off toward the edge, just like the depth of a sphere does. And then the final touch that I need to add is a square root node. And this is going to add that curvature so that I get the curve of a sphere. Okay, so this is the first piece of the sphere that we needed to calculate. I've created the depth of a sphere here. The next thing that we need to calculate is the normals of the sphere, or basically which direction the sphere is facing. And in order to be able to do that, I need to take the depth, that's going to be the z component of the normal, and then the x and the y components of the normal are going to be the x and y, or the u and the v coordinates. So I'm going to add a split node right here. And then I'm going to combine the u and the v coordinate with my depth. So I'm going to add a combined node over here. And we'll take the u coordinate and the v coordinate and the depth. And now I've got the normal. Now there is one more thing that I need to do to this normal. I need to mask out the edges around the outside of the circle. But I'm not quite ready for that. And so I'm just going to leave this for now. And next we're going to work on creating the mask for our circle. And that's pretty easy to do as well. I can just take this, the result of this dot product here, and apply our anti-aliasing node that we've created previously. This one takes in a gradient and returns an anti-aliased version of it. So I'm going to pass my gradient in here, and you can see I've got a nice anti-aliased edge now. And I'm going to set my cutoff to 1. And now I've got a nice mask for my circle, but it's inverted. And so I need to fix that just by adding a 1 minus. And now you can see that kind of slowly the components of our sphere are coming together. We've got an outer edge mask, we've got depths, and we've got our normal. But let's go ahead and finish off our normal now. We can blend between this. I'm just going to add a lerp node. So we're going to use our mask. And wherever our mask is white, we want the normal from that we calculated here. And wherever it's black, we want the default normal, which is 0, 0, 1. Okay, that's it. So we've got our normal, we've got our depth, and we've got our edges mask. There is one more component that we need to add, and that is we want to calculate the diffuse lighting on our sphere. And we've got the normals, so we should be able to use the normal to calculate diffuse lighting. The one thing that we're missing is the direction of the light source. And so I'm going to come up here to our blackboard and add a vector 3. And we're going to call this light direction. And for the default value of light direction, I'm going to make this negative 0.7 and 0.7 and 0.7. So we'll bring in our light direction. And because the user can put this value in, we want to make sure that it's normalized. And so I'm going to add a normalized node here. And now we can calculate the diffuse lighting using our light direction and our surface normal. And all I have to do is do the dot product between my light direction and my surface normal. And boom, we have a lit 3D sphere. This is pretty cool. All right, well, we're all set here. Let's go ahead and set up our output and create the outputs that we need here. So the first thing that we need here is a float, and we're going to call it diffuse. And we can hook up our diffuse lighting to that. The next thing that we need is the normal. So I'm going to pick a vector 3, and we're going to call it normal TS, because I want to make it clear that this normal is in tangent space. And we'll hook up our normal there. The next thing that we need is our depth. And we'll just call this depth, and it's a float. And we'll connect up our depth there. And then the last thing that we need is our mask. So I'll just connect our mask right there. And now we have all the components that we need to create the 3D shape that makes up the core of that fantasy meter effect. So next week, we're going to use this data to start creating that glass sphere effect that we looked at the beginning of the video. And we'll probably add some specular and diffuse lighting. It's going to be great. Hope you come back next week for those. And in the meantime, let's go ahead and switch over to Unreal, and I'll show you how to create this effect there as well. All right, here we are in Unreal, and we're going to do the same thing that we just did in Unity. We're going to create a sphere gradient material function. So let's come here to our gradients folder. Oh, and by the way, just like I showed you in Unity a minute ago, these are all of the material functions that we've created for creating shapes and patterns and user interface and other 2D elements that we've been working on in this series. And just like I said a minute ago, I've linked all of these, how to create them, down in the description. All right, so I'm going to go ahead and right click here and pick material function. And we're going to call this sphere gradient. And we'll open it up and get started. So the first thing that we need to bring in is our texture coordinates. And so there's our texture coordinate node that brings in our default texture coordinates. But we want to create an input that will allow the user to pass in their own UV coordinates if they want to. So I'm going to add a function input here, and we'll set this to a vector 2 for UV coordinates. And we'll call this UV. And check the use preview value as default, and then we'll connect up our preview value with our texture coordinates there. All right, we're all set with texture coordinates. Now what we want to do is give the user control over the scale of the coordinates. So let's come down here to our procedural folder and pick UV and scale, and we'll connect this up to our UV coordinates here. And now we want to give the user control over the scale. So we need to add a new input here. We'll add a function input, and let's set this to a vector 2. And we'll call it scale. And we're going to give it default values of 0.9 and 0.9. And pick use preview values default and connect that up to the scale. So now I can use this input here to control the scale of my UV coordinates. The next thing that I need to do with my UVs is, right now, let's see if we can preview this node here. Just set up our preview. I really like the field of view set to 50 degrees, so we're going to do that. All right, you can see our UV coordinates coming in here are centered in the top left, and we want to center them in the center. And so in order to do that, we can multiply by 2 and subtract 1. So there's our multiply by 2 and subtract 1. And if we preview this now, you can see that we've got our coordinates centered in the center. So now that we have our UVs set up, we're all ready to start creating the components of our sphere. The first component that we're going to create is the depth. And in order to create the depth, I'm going to take the dot product of our UV coordinates dot producted with themselves. And I'll show you the result here. This is going to measure the distance from the center. So in the center, our distance is 0, but then as we get further away, our value is getting higher and higher. So in order to convert this that we've created here into the depth of our sphere, we're going to add a saturate node. This is going to prevent the value from going higher than 1. So here in the middle, we have a value of 0, but then out toward the edges, it goes further out than 1, and the saturate node prevents it from doing that. Now, in order to create the depth of a sphere, we actually want the inverse of what we have here. And so that's easy to do. I can just add a 1 minus node to flip our values around. And now, in order to correct our gradient here, right now we have a linear gradient from 1 to 0. And what we actually want is a curved gradient. And so in order to add that curve, we're going to find the square root of this value. And if I preview this, now you can see I've got the depth of a sphere. And this is fantastic. So this is the first component that we needed to calculate in order to create our sphere, is this depth. So here in the front is closest to the camera, and then it curves around slowly to the side here where our depth falls off. Okay, cool. Next, now that we've got our depth, next let's create our normal. And our depth is one of the components of the normal. So now that we have that, the rest of it is actually pretty easy to create. We're going to start off with our UV coordinates here that are coming out of this subtract node. And that is going to be the X and the Y. And then we just need to append our depth as the Z. So I can create an append vector node here. And we'll start out with our X and our Y, or our U and our V coordinates here. And then we'll connect up our depth. And if I preview this, now you can see that we've created the normals for our sphere. So this is fantastic. This is exactly what we wanted. But there is one more thing that we need to do here, and I don't have what I need yet to do it. And so let's go ahead and create the next component, which is the mask. We need to be able to mask out the edges of our normal. So instead of getting this weird like black and red and yellow and blue, we want our normal to be flat outside the sphere. So let's create a mask that determines the boundaries of the sphere. In order to do that, we're just going to add our anti-aliasing node, and we're going to take this gradient that we created with our dot product and plug it into the gradient input of our anti-aliasing node. Again, this is one of the nodes that we created previously in the series, and the link is in the description for where we created this one. And we want to set our cutoff value for our anti-aliasing to 1. And then we want to add a 1 minus node to invert the result. And if we preview this 1 minus node here, you'll see that we've got a nice mask for the outside edge of our sphere with a really beautiful anti-aliasing outline. So we can use this mask to fix our normals here. So I'm going to add a lerp. Here's our lerp. And wherever the lerp, or wherever our mask is white, we're going to want to use this normal. And wherever it's black, we're going to want a default value of 001. And so I'll just go ahead and pass this value into our lerp. And then if we preview our lerp node here, now you can see we've got a really nice normal sphere with the outside just being the flat 001 blue normal color. Okay, so far we've calculated the depth, we've calculated the normal, and we've calculated the mask. So here's the mask. In fact, I'm just going to add labels to these so we remember. This is our mask. This is our normal. And then this is our depth. Cool. there's one more component that we want to add, and we actually want to calculate the lighting for our sphere. So let's do that next. And in order to do that, we need to add a new input for a light direction. So this is going to be our light direction. And I'm going to give it a default value of 0.7, 0.7, and 0.7. And because we have the light direction and the surface normal, we can really simply compute the lighting for this sphere by just doing a dot product between the light vector or the light direction and the surface normal. Basically, what we're doing here is we're looking at the direction the surface is facing, and we're looking at the direction the light is facing. And if the two of those are lined up or parallel, we know the surface is going to be bright. But if they're perpendicular or pointed away from each other, we know that the surface is going to be dark. And we do that comparison, that vector comparison, using the dot product. Oh, I just want to make sure that I click this use preview value as default. So we're going to plug our light vector in here. Oh, and I forgot to name this. I need to call this light direction. So we're going to plug in our light direction and do a dot product with the surface normal. And now if we preview this, you can see that we get a really nice lit sphere. Now our light's currently coming from the lower right, and I think we need to adjust this a little bit. So let's change the direction of our light source. All we have to do is negate the x and the y, so negative 0.7 and negative 0.7. And now we have a light source that is coming from the upper left, which is where I want it to be. Oh, there is one thing that I forgot here. For our light direction, because the user can type in whatever values they want, as a safeguard, I'm going to add a normalized node here. And what that's going to do is it's going to make sure that the value coming in from our light direction is a unit length of 1. And that's important because our normal is a unit length of 1. We also need our light direction to be a unit length of 1 in order for this dot product operation here to work correctly. If we don't do that, we'll end up with some results that don't look correct on our diffuse lighting here. All right, I think we're all ready to pass these values out. So let's go ahead and set up some outputs. Our first one is going to be diffuse. So we'll just name that diffuse and connect up the output of our dot product. Our second one is going to be our normal. So we'll just name this normal and pass out the result of our lerp here. So you can see I've got our nice diffuse lighting. I've got our normal. The next one is going to be our depth. So I'll connect up our depth value. And we need to make sure that we name it depth. And then our last one is going to be the mask. And so we'll just name this mask and connect up our mask. Cool, so now you can see we've got all the components that we need. We have our diffuse lighting, we have our normal, we have our depth, and we have our sphere mask. And now we can use these components to create our fantasy meter. So next week we're going to start using this sphere gradient node that we've created to build our fantasy meter. I'm going to show you how to do specular lighting. So here I've done diffuse lighting, but we're going to create a little specular highlight on our glass sphere. And we'll use our normals and our depth and our mask to do that as well. So come back next week to see the next part of the series on building this fantasy meter. All right, I hope you enjoyed today's video and have a great week, everybody.